In May 2019, SpaceX successfully launched the first 60 satellites of their Starlink constellation. According to FCC filings, eventually there'll be 1,584 satellites in this first phase, spread across 24 orbital planes. 60 satellites just launched are currently in the process of raising orbit, and we can see from NORAD tracking data that they're all heading for a single orbital plane. Before launch, Elon Musk talked about when Starlink would first be able to provide service.
Yeah, I think it's just important to distinguish between initial operational capability, which is around the 400 satellite level, and then significant operational capabilities around the 800 satellite level, and then thereafter it's about adding more and more satellites and more orbital planes of satellites as we get more usage of the system and we get bandwidth constrained. But there is that, like, you need that initial sort of 6 planes minimum to have at least some level of continuous connectivity for portions of the world.
This is what 6 orbital planes at 53-degree inclination, comprising almost 400 satellites, looks like. The blue circles show the limit of coverage of each satellite. Although there are dense bands of connectivity, at any one time there's no coverage over much of the world. This first generation of satellites don't have any inter-satellite links. Instead, SpaceX initially plans to achieve long-distance connectivity by bouncing the signal from one satellite to another off a ground station, and having these dense bands of satellites helps this work well. Despite these gaps, even with 6 orbital planes, there will be some regions of the world that have continuous connectivity. Due to the orbital inclination, these bands are located around a latitude of 50 degrees north and 50 degrees south. So, let's take a look at which regions will be covered when Starlink first starts operation. In North America, Canada is pretty well covered, but only the northern United States has continuous coverage. Elsewhere, the satellites are only overhead for a part of the day, and not the same time each day either. Let's spin the world. It doesn't really spin this fast, and it spins the other way, but this gives a good idea of where we'll be covered. On the east coast, New York City is just within the continuous coverage band, but nowhere further south is. Further out to the east, Newfoundland looks like a good place for a Starlink ground station to relay signals out across the Atlantic. If SpaceX plans to provide transatlantic long-distance service with this generation of satellites, it looks like they'll need relays on some ships. Iceland is just too far north and the Azores are too far south. Most of Europe gets good early coverage. In the south, Spain, the southern tip of Italy and most of Greece miss out. In the north, Finland and much of Scandinavia are also not covered until sometime in a later Starlink phase. Continuing east, Ukraine and most of Russia are well covered, though whether Starlink will ever get permission to provide service there is still an unanswered question. It's easy to forget how big Russia is. Most of China is too far south for this early stage, but again, getting permission to operate there might prove difficult. Northern Japan gets coverage, but Korea misses out. From here, it's just the Pacific Ocean, until you eventually reach the southern coast of Alaska, which also gets coverage. So, what about the southern hemisphere? Where does the coverage band that lies around 50 degrees south cover? In fact, there's not a lot of land around 50 degrees south. Southern Argentina and Chile will see continuous coverage. Let's speed up a bit here. South Africa is too far north. Lots of satellites over the Southern Ocean, but not really any people there. Australia is just a little bit too far north, but Tasmania gets good coverage. And the South Island and New Zealand also gets pretty good coverage. That's about it in the Southern Hemisphere. If things go to plan, by the end of 2020, SpaceX should have completed 12 orbital planes and be halfway to completing the first Starlink phase. 12 orbital planes provides complete coverage over all of the continental United States, though northern Alaska is still not covered. Let's spin the world again. You can see there are still some gaps in the coverage further south, over the Caribbean for example, or further south near the equator. Southern Europe and North Africa will now have full coverage, though northern Norway, northern Sweden and Finland still miss out, as does Iceland. Most of the Middle East gets coverage, though Saudi Arabia is only partially covered, and coverage is still patchy in India too. Most of China now has coverage, if their government decides to take advantage, and now Korea and Japan are covered too. If we zoom out, you can see those gaps over the equatorial region, with smaller gaps further south over Brazil. Argentina now has pretty much continuous coverage, as does South Africa, but you can see there are still gaps further north, areas like Kenya. Let's skip forward. Things are now looking much better for the southern half of Australia, and last but definitely not least, New Zealand now has full coverage. So that completes the Starlink World Tour. I hope that's been useful in getting an idea of which areas will and which areas won't be covered in the early stages of running the Starlink network.